Hello everyone, very good morning you all. I am Mr. S.K. Hota, Assistant Professor in College of Pharmaceutical Sciences Mahuda in the Department of Pharmaceutical Chemistry. Today I am delivering the lecture about fats and oils. The main objective of the lecture is, I'll explain you today about what is fats and oils, what are fatty acids and what are the reactions of fatty acids. What is fats and oils? Fats and oils are the major components of lipids. Fats and oils are natural group of compounds called lipids. Naturally, we'll get fats, example ghee. Naturally, we'll get oils like all the edible oils, cooking oils like sunflower oils, cottonseed oils, coconut oils. So these are the fats and oils we'll get naturally. So fats and oils are natural group of compound called lipids. These are also called as triglycerides, means fats. Then how a fat is formed? A fat is formed. How a fat is formed? How a fat is formed when one molecule of glycerol condensed with three molecules of free fatty acid to form a fat. One molecule of glycerol condense to form three molecules of free fatty acid. Why it is called as free fatty acid? Means the three acids are not connected to each other. That's why it is called as free fatty acids. And in the glycerol, the hydroxyl group is the main backbone of fats and oils. So when a glycerol condense with three molecules of free fatty acid on hydrolysis to form an ester, ester is the main functional group RCOR. Okay. So here I have taken three molecules of fatty acid. So three ester molecule connected known as triglycerides. And this is called as a triester. When this is called as triester of glycerol, or we call it as fat. Okay. Next. Then what is fatty acids? Fatty acid means what? Long chain of carboxylic acid are known as fatty acid. The main functional group of fatty acid is RCOH. Here R is the aliphatic chain. Suppose in R, CH3, CH2, CH2, and the main functional group is acid is QH. So here I have taken three aliphatic chain. So total compound is butyric acid. So butyric acid is an example of free fatty acids. Then types of fats. There are two types of fats, saturated fat, unsaturated fats. Saturated fat means what? Fats don't have double bonds. Unsaturated fat means what? Fats have bonds, many bonds. Coming to saturated fatty acid, having the functional group RCOH and having the general formula CnH2n plus 1 COH, acetic acid, propionic acid, caprylic acid, palmitic acid, stearic acid. So propionic acid is CH3, CH2, COH, caprylic acid is C17, H15, COH, palmitic acid is C15, H31, COH, stearic acid is C17, H35, COH. So generally for fat preparation, okay, for fat preparation, generally higher fatty acid, higher saturated fatty acid like palmitic acid and stearic acid are used. See, I have given the diagram, palmitic acid and stearic acid. Here no bonds, that's why it is called a saturated fatty acid. Unsaturated fatty acid means what? Oleic acid, linoleic acid, linoleic acid. So you have given the structure of oleic acid. In that structure, the carbon 9 and carbon 10 position double bond is there. Oleic acid here double bonds unsaturated means what? Presence of double bond. If only one double bond is there, that we call as one example oleic acid. Oleic acid is an example of unsaturated fatty acid, or also called as presence of only one double bond, that is called as MUFA. MUFA means monounsaturated fatty acid, and linoleic acid having two double bonds, 6 position and 7 position and 9-10 position, two double bonds are there. So linoleic acid is an example of unsaturated fatty acid. So now we'll get the proper definition of fats and oils. Fats means what? Fats and oils are nothing but triesters. So when we properly define the fats, these are the fats are what? Triesters of long chain of saturated fatty acids with glycerol, whereas oils are triesters of long chain of unsaturated fatty acid with glycerol. So when you prepare the fat, then you have to take either stearic acid or palmitic acid or stearic acid, highly unsaturated fatty acid. And when you prepare the oils, then you can take either oleic acid or linoleic acid or linolenic acid. Okay, suppose when you use in fat, when you use stearic acid in the ester, in the triester, okay, triester means CH2O COR, CHO COR, CH2O COR. In the R place, when you use a stearic acid, that we call as a tristearine. In oil cases, in the triester place, when you use oleic acid, that is known as triolene. So tristearine is an example of fats, whereas triolene is an example of oils. Fats and oils are two types. When you can define simple fats, is one type of fats and mixed fats. Simple fats means what? When the three fatty acids of triglycerides are same, means CH2O COR, CHO COR, CH2O COR, where all the R groups are same of triglyceride, that we call as simple fat. And when all the three fatty acids of triglycerides are not identical or different, that we call as mixed fats. This is one important about fat versus oils. We'll discuss about differences about fats and oils. Already we got the definition of fats. Fats are esters of saturated fatty acid with glycerol, whereas oils are esters of unsaturated fatty acid with glycerol. Only difference is what? Fats are saturated fatty acid, oils are unsaturated fatty acids. And fats are animal sources, example ghee, cheese, butter, whereas oils are plant sources, example coconut oil, sunflower oil, sesame oil, castor oil. It is either a solid or semi-solid at room temperature. Fat is either solid or semi-solid at room temperature, and oils, it is liquid at room temperature, because fats and oils are nothing difference, only difference is temperature difference. When we give temperature of ghee, then it melts, it is converted to oil. So fat is solid or semi-solid room temperature, and oil is liquid at room temperature. Fats are saturated compounds. Example tristearine, already I've given. Oils are unsaturated compound. Example triolene, because stearine having stearic acid structure, having no bonds, and that is saturated compounds, that is tristearine. And oleic acid in oils, that is unsaturated compounds. So oils are unsaturated compounds, fats are saturated compounds, and fats have high melting points, and oils have low melting point. If you see the structure of stearic acid and oleic acid having the carbon C17, okay, stearic acid having the melting point 69 degrees centigrade, oleic acid having the melting point 13 degrees centigrade. So if you compare the melting point of oleic acid and stearic acid, melting point of stearic acid is higher than oleic acid. That's why fats have high melting point and oils have low melting points. And fats are stable, are more stable, oils are less stable. Okay, next. Now I will discuss the important reactions of fats and oils. The chemical reactions of fats and oils reflect the reactivities of ester linkage, degree of unsaturation, and the hydroxyl group. Because I told you the hydroxyl group of glycerol, which is the backbone of fat and oil. So in the reactions of fats and oils, I will explain you so many reactions. So all the reaction is based on the reaction involving acid group and the reaction involving carbon-carbon double bond, means alkene. The reaction involving the acid group, generally hydrolysis, saponification reaction occurs, and the reaction involving alkene, means carbon-carbon double bond, hydrogenation, rancidification occurs. So I will explain about the reactions. There are so many important reactions of fats and oils, like what? These are the important reactions like hydrolysis, hydrogenation, saponification, rancidity of oils, drying of oils. Now I'll explain about hydrolysis. What is hydrolysis? Hydrolysis means what? Lysis means breakdown. Lysis means breakdown. So what happens when a fat react with water molecules? So generally hydrolysis is done by either on water and in presence of enzyme. I have taken the fat under hydrolysis. Hydrolysis means I have treated with water molecule. H2O react with H plus plus OH minus. So fat is nothing but triester. So three molecules of water I have taken. So in presence of hydrolysis is done by enzyme known as lipase, because for digestion, generally digestive tract lipase is responsible for digestive tract of animals. So generally lipase helps for hydrolysis. Lipase is an enzyme helps for hydrolysis, and mm, hydrolysis is also done by in presence of or in presence of uh, hydrolysis is also done by in presence of oxidizing agent like zinc oxide. Zinc oxide is used as a catalyst. Okay, so hydrolysis is done by either enzyme or by water. In presence of enzyme and water, in presence of enzyme lipase is responsible, and in presence of water zinc oxide is a catalyst under pressure at 443 degree temperature at 443 degree Kelvin and 6 to 8 atmospheric pressure. Then what will happen is the fat under hydrolysis. Three molecules of water have taken lipase under pressure to form. It will be formed what fat form glycerol and free fatty acid, because H plus plus OH minus ion, and here RCOH, three molecules of free fatty acid will form, and glycerol is separated, because I told you glycerol is the main backbone of fats and oils. So glycerol is separated, remaining free fatty acid will be formed. Next, hydrogenation. Hydrogenation means what? Hydrogenation means addition of hydrogen molecules. Generally, vanaspati ghee is prepared by this process. In hydrogenation means what? Liquid oil in the presence of hydrogen gas and a nickel catalyst, or a finely divided nickel catalyst under pressure, oil converted to semi-solid fat. So I have given the what is the hydrogenation? When hydrogen is passed through oils under pressure and by using nickel as a catalyst at high temperature, oils get converted into solid fats. This process is known as hydrogenation, or also called as hardening of oils. Here what liquid oil, I have taken the example in the steering or fat I have used oleic acid. The compound is known as liquid oil compound is known as triolene, is an oil. Uh, the meaning is one hydrogenation for conversion of for formation of triolene to triostyrene. See H33 see the triolene C17 H33 all the esters in C, all the three esters H33 in triolene, whereas in tristirene H35. So 6 more hydrogen is required for hydrogenation process to convert triolene to triostyrene. Okay. Next one is saponification. Process of formation of soap is known as saponification. And this process of means what? Here it means in saponification process, uh, on hydrolysis we call as alkaline hydrolysis. So alkaline hydrolysis of fats and oils to form salt of fatty acid is known as soap, and the process is known as saponification. So we'll take the fat, we'll go for alkaline hydrolysis, like alkali like NaOH or KOH is used, and we'll go for hydrolysis that we call as alkaline hydrolysis. Alkaline hydrolysis, fat under hydrolysis with alkaline agent NaOH or KOH to form glycerol will be separated, and here NaOH is used. So our final compound is what? Salt of fatty acid. What is the meaning of salt? Salt means what? A salt consists of two parts, a metal part and another one is non-metal ion from the acid. Main thing is the metal part. Here metal part is what? In alkali NaOH, Na is the metal part. A metal part is used in the acid. COH in hydrogen plus metal is used. So suppose the name of the particular compound is what? C17H31 COO Na. When NaOH is used, H plus plus NaO minus. So H plus is used, C7 H31 CO, metal is used, Na. So what is the name of particular compound? So COH means carboxylic acid, CONA means CO minus means carboxylate, CO minus CONA means sodium carboxylate. I have used C17. Actually, I have tripalmitic palmitic acid formula is C15H31. Okay, so C15H31 CONA means what? Sodium. What? Sodium palmitate. Okay, this is called as soap. So alkaline hydrolysis of fats to form salt of fatty acid is known as soap, and this process is known as saponification. So soaps are of two types: hard soap and soft soaps. Hard soap cases, what alkali NaOH is used. Soft soap cases, alkali KOH is used. And soaps are used for cleaning properties. Soft soap is better cleaning properties than hard soap. Soap molecule have both hydrophilic and a lipophilic group. Hydrophilic means water loving, and lipophilic means lipid loving group. The lipophilic group dissolves oil, while hydrophilic group dissolves water. Soap molecules on dissolution water to form micelle. Okay, then generally, if I'll discuss about for soap preparation and detergent preparation, for soap preparation, natural material, fat or oil you have to take, either ghee or any oil like coconut oil, or any oil you have to take. Detergent, the synthetic material, petroleum used as a raw material. And soap generally contains alkali plus fatty acid. Here main alkali soap preparation NaOH. For detergent preparation, main alkali is potassium hydroxide, and in soap preparation fatty acid is used, and for detergent sulfuric acid is used. Okay, this is all about saponification. Next one is rancidification. Rancidification means what? Rancidity means, what is the meaning of rancidity? Unpleasant smell and odor, unpleasant taste and smell is called as rancidity. What is the meaning of rancidification? On long storage and in contact with air, moisture, and sunlight, oils undergo decomposition and start smelling unpleasant. This process is known as rancidification. Okay, when oil comes in contact with air, moisture, and sunlight, it starts smelling unpleasant. It will be degrade and start smelling unpleasant. This process is known as the rancidification. Fat should not call as the rancid. Oil is said to be a rancid oil. So one more thing, rancidity occurs by the following causes: oxidation of unsaturated acid. This is the main causes of rancidification. Oxidation of unsaturated acid to form, what will happen? So first thing is what? Peroxide will be formation, and this peroxide break down aldehyde group, and aldehyde groups are the main responsible for rancidity. So here I have taken the example of I'll explain you rancidification. Here I have used oleic acid is an oil because oil is said to be rancid. So I have used oleic acid, and the oleic acid, here the double bond is there. Okay, there what will happen? Rancidification, then it comes in contact with air, means comes in contact with the oxygen. What will happen? The where the double bond is there, means pi bond helps for contact with the oxygen to form peroxides. Okay, and these peroxides break down to form HCO plus HCO, and the HCO means main functional group is known as aldehyde, and these aldehyde groups are the responsible for rancidity. This is all about rancidification. This is the main topic, drying of oils. What is the meaning of drying of oils? Drying of oil. I'll explain you what is the drying of oils. A drying oil is an oil that hardens to a tough solid film after a period of exposure to air. Okay, that is called as drying of oil. And this is the main process of drying of oil is known as oxidation, and next is polymerization. After oxidation and polymerization, to form a thin water film is called as drying of oil. And I will explain you about the chemistry of drying. Chemistry of drying involves oxidation process. See, in drying of oil, generally highly unsaturated oils are used. I have given the example, diene is a highly unsaturated oil. I have given the structure of a diene because two double bonds are present, that we call as diene. Under oxidation, first is what our main aim for drying of oil is what? Oxidation. So diene, under oxidation, what will happen? So here 3-4 position double bond is there, 6-7 position double bond is there. So self oxidation means either one of the double bond. Suppose 6 position, 7 position, oxygen O2 will be attached. Then what will happen? Bond is shifted to 5 to 6 position, and oxygen means O2. Okay, 7 position O2 is oxidized, means O2, and oxygen balance is 2, 1, 2, 2 bonds are there, and last terminal oxygen only balance 1. That's why I have given hydrogen. Okay, because hydrogen 1 and 1 bond, oxygen balance is 2. So hydrogen peroxide, hydroperoxide. Peroxide means what? Only one oxygen is oxide, two oxygen means peroxide. If hydrogen contains peroxide, that is hydroperoxide. Now we got a diene under oxidation to form a particular compound known as hydroperoxide. there is the oxidation process. Next step is what? Polymerization. In the polymerization means what? A cross-linking process. In the cross-linking process, what will happen? So by the action of oxygen means a hydroperoxide when cross-linking with a diene to form by the action of oxygen, there is a evaporation of water molecule, means the loss of water molecule to get a particular compound. There is a loss of oxygen is the main involved for attachment of certain position. So action of oxygen, water molecule is uh, eliminated of water molecule to form a particular compound during polymerization process. So drying of oils, the main oxidation or that we call it oxidation process. Next process is polymerization. We'll get so many oil from drying process. And drying can be achieved by faster by the addition of dryers like salt of manganese, lead, cobalt, etc. Drying of oils. There are so many drying of oils like main drying of oils, semi-drying oils, non-drying oils. Generally, drying of oils are used as a medium for paints, varnishes, and lacquers. Okay, so for a clear finish of furniture, we are using so many drying of oils. What is the meaning of drying of oils? Drying oils. Drying oil means what? They form a solid elastic film. Solid elastic film, that is known as drying of oil. And semi-drying oil means what? These oils have a high level of linoleic acid and low level of linolenic acid. Okay, and drying of oils means what? They form a solid elastic film. A good drying oil dries within 4 to 5 hours, and generally linseed oil, poppy seed oil, walnut oils are these are the oils are used for drying oils, and for semi-drying oils, sunflower oil, cottonseed oil, castor oil, mustard oil, sesame oil. These are the oils having high level of hyaluronic acid. So these oils are used for semi-drying oils. And the meaning of non-drying oils. The meaning of a non-drying oil is what? Non-drying oil means what? In non-drying oil, non-drying oil is not having any, which doesn't hard when it exposed to air. That is known as the non-drying oil. Okay, which doesn't harden with the when it exposed to air, that we call as non-drying oil. Example: olive oil, almond oil, and peanut oil. So these are all about drying of oils. Thank you.